Okay, so in this clip, we're going to look again at the reactivity series, which has obviously now got more metals into it over the various clips and discussions that we've done. We can see that we've got the more reactive metals present as the group 1 metals. We then have obviously the group 2 metals, group 3 then moving into transition metals. And what we have done is we have used, prior to this, observations with the reactions with water, or by observations of the reactions with carbon to know whether or not a substance is more or less reactive than carbon, and also looked at the difficulty of which we needed to extract carbon, or use carbon to extract it. For example, with iron and copper, we knew that a higher temperature was often needed for iron than with copper. Gold and silver are native metals, and so we could put some of these metals towards the right hand side in terms of reactivity by observation of how they react with carbon. But what we're going to do this time is we're going to try and insert hydrogen into this reactivity series as well. Again, this is a non-metal for the purposes of this, but we can look at the type of reaction that will occur between a metal and an acid being a source of hydrogen, H plus ions essentially, but essentially being a way of introducing hydrogen into the reactivity series by producing a salt and hydrogen gas as a byproduct. But we can, in the same way we could insert carbon into the reactivity series, we can also now insert hydrogen by testing whether or not a metal will react with hydrogen, with the acid, therefore allowing us to figure out whether or not the metal was more or less reactive than hydrogen. And to go directly to the answer, we know that hydrogen is actually relatively unreactive. We know that we can place hydrogen into the reactivity series there. Anything including and below copper in terms of reactivity won't react with acids to produce hydrogen. Everything higher than, on this series, iron and higher reactivity series, going all the way through group 2 to group 1 metals, react with the acids to produce hydrogen and a salt. But what we can also see is that during that reaction, we can couple this to a rates of reaction observation and see the vigor of which the reaction occurs. And so we can start to actually now link two areas together, and also by doing so give further evidence for the reactivity series of the metals by seeing that the reaction vigor, the way in which the hydrogen is given off, gets more vigorous as we go towards the top end of group 1 reactivity. So potassium reacts very vigorously with an acid, lots of bubbles of hydrogen very, very rapidly. And then the closer we get to iron in that series, the reaction gets less and less vigorous to the point where it appears to be relatively slow. Copper then stops reacting altogether. And so we can do a comparison of those reactions and not only place hydrogen in the reactivity series in that position there by whether or not it does or doesn't react, but we can then also look at the vigor of the reaction to give us more evidence for the actual positions of the metals within the reactivity series here.